Hello and welcome. Today we are going to learn about waves and all the concepts or problems that you have in the in waves. You can watch this video all through the end, and by the end of this lecture, you will be feeling very happy. Okay, and in this lecture, we are going to cover in some parts what is wave, time period, frequency, what is crest, trough, wavelength, what kind of graphs waves do have, what is node, antinode, what are the types of waves, rarefactions, compressions, phase difference, lead and lag concept, interference, superposition, path difference, how to calculate the path difference, phase difference, how to calculate the phase difference, how to evaluate whether some points are in phase or not in phase. Okay, so we will do all this in this lecture. So please stay with me. Okay, so what is wave? Wave is the transfer of energy from one point to another point without transferring the medium. Now, what does it mean? It means if you throw a pebble in water, the waves will propagate from the point where you throw the pebble to some other point, like far away, right? But the water will remain staying, water will stay there, right? The water is not moving out, just the waves are moving out. Just the energy is transferred from one point to another. The water will remain there as well. So it means the particles of the medium do not travel, they just vibrate. Just like here, you can see the pen is not moving itself. The energy is just propagating from one point to another point, and everything is staying at the same place. Similarly, you can see when we are doing this, the energy is propagating in all directions, not just one direction. So the points where the amplitude or where the distance of the particles from mean position is zero, we call them as nodes. And the point where they have the maximum vibration, we call them as antinode. Node are those points where the amplitude or the vibration of the particles is zero. Okay. And the points where you have the maximum vibration, you call them as an amplitude. Sorry, antinode. And the points where the amplitude is maximum are antinodes. So what is amplitude? Amplitude is the distance between mean position and extreme position, or the points where you have the maximum vibration. So here, the points are like this. So this point is actually um, amplitude, amplitude, and amplitude. This is also amplitude, but in negative, and this one is in positive. Okay, like that. Now, what is time period? Time period is always time to complete one wave. Okay, so from here you can see the wave is starting and completing one cycle here, because this is one half and this is another half. So half and half full. And the time taken by the wave to complete one cycle is called time period, which is 0.5 here. And in 1 second, how much waves do you have? That is called frequency. So in here you have two waves in one second. Therefore, the frequency is 2, but the time period is 1. Now, what is crest? Crest is the point where the vibration is maximum but in positive direction. And trough is the point where vibration is maximum but in negative direction, or the point of positive maximum amplitude. And trough is the point of negative maximum amplitude. Okay. And what is wavelength? Wavelength means the length of one wave. And what is one wave? You start from here. This is half and this is half. This is full wave. So that is also called one wavelength. Okay, and one wavelength is actually equals to 360 degrees. Can you see? Because this is 1D, you can see 1D, and 1D means 180 degrees, right? And this is another D, so that means 180 degrees. So 180 and 180, 360. It means one wavelength always corresponds to 360. For example, in here, you have this 180 and you have 1/4 in here, and quarter of a 360 is actually 90, 90, 90, and 90. So it means this is 90, this is 90, and this is 180. So that makes 360 as well. Okay. Now, what kind of graphs do waves have? The waves are having two kind of graphs. One is displacement time and one is displacement versus distance. So displacement versus time graph always gives you time period, not wavelength. And the displacement versus distance graphs always gives you the wavelength, not the time period. You need to remember this, okay? Types of waves, you have two types of waves. One are mechanical waves and one are electromagnetic waves. Mechanical waves are those waves which require medium to travel. For example, you and me are talking, and all of a sudden somebody put a vacuum between you and me. Now you won't hear me and I won't hear you because there is no air between you and me. There is a vacuum. So sound waves are actually require medium to travel. And when there's no air, it means there's no medium or there's nothing that takes my voice to your ears because there's no medium, right? So those waves which require medium to travel are called mechanical waves. Okay, and electromagnetic waves are those waves which require no medium to travel. For example, sun is creating light and bringing it back to Earth through space. So space has no air, nothing, but still it is trespassing. It is transferring from sun to Earth. It means electromagnetic waves do not require any medium to travel. What are transverse waves and longitudinal waves? Now you can see there is a spring in here and the wave is being propagated in these two springs. And one spring is moving up and down while transferring the energy, okay? And one spring is getting shrink when the energy is transferred from that, okay? So we have two kind of scenarios here. When energy moves, the spring moves up and down and the wave is moving this direction. So both of them have an angle of 90. And in this, when waves pass from here, you can see the spring got compressed and the motion of the spring and the motion of wave is same. So in both cases, you can see that the particle of the medium, which is spring, it's not going anywhere. The spring is staying at the same place, but just the energy is getting transferred, right? So now we will say that those kind of waves in which medium travels perpendicular to the direction of wave are called transverse waves. And those waves in which medium travels parallel to the direction of waves are called longitudinal waves, okay? Now for longitudinal waves, you can see that the spring was getting compressed, but in transverse wave, it was not like that. It means compression and rarefaction is the concept purely associated with longitudinal waves, not transverse waves. In transverse waves, when the energy is transferred from a medium, the spring remains like the same. It's just moving up and down. But in transverse waves, when energy is transfers from a spring, the spring is getting compressed. It means the particles are coming closer to each other like that. So that is called compression. So compression is the point where particles are very close, or you can see a point of maximum pressure. And the rarefaction is the point when wave is gone, the particles become relaxed again, they move away from each other again. So the point or the area of minimum pressure are rarefaction. And what about one complete wave, one complete longitudinal wave? How much fraction and how much rarefaction and compression it has? So one complete longitudinal wave only have one compression and one rarefaction. Okay, you need to remember it. Here, the one longitudinal wave is completed, and from here another longitudinal wave is started.